Welcome to The Future Is, the podcast where we meet the people shaping what's next in business and life. I'm your host, Laura Kelleher, Honeywell's Chief Marketing Officer. Have you ever wondered what it would be like to fly above street traffic? Taking transportation from the road to the air is not that far off a concept. In fact, technologies and systems are already being developed to make that transition easier, so you may get to ride in a taxi flying above the street in your lifetime. And here today to talk about this and more is David Shilliday, our Vice President and General Manager of Urban Air Mobility and Uncrewed Aerial Systems. Thanks for being here with us today, David.
Thank you, Laura. I love the opportunity to talk about it.
So to get us started, can you give our audience an intro to the world of urban air mobility? Help us understand what the everyday person should know about this category of aviation and what it could mean for them in the future.
Love to. So when we talk about urban air mobility, that's a bit of a catch-all term to talk about a wave of disruptive vehicles that are appearing today. And if we can be a little more detailed in what they are, one of the first ones you'll think of are what are called eVTOLs, or electric vertical takeoff and landing. And these are the Archers, the Jobies, the Liliums, the Verticals. And the concept of these vehicles is they can take off vertically, they can then go into cruise, and then land, and typically take off and land on something the size of a pickleball court, or what my generation would refer to as a tennis court. And the big difference between that and something like a helicopter is these vehicles do that via a number of electric motors rather than one big gas turbine motor, and using unique design architectures. They're able to fly more quietly, orders of magnitude more quietly, more efficiently, and also at a very low cost point. And so it gives people the ability to fly from regions that historically would have been very challenging at a price point and with an environmental impact that's much lower. The next type of vehicle you might hear about is something called an eSTOL, or electric short takeoff and landing vehicle. And this is going to look more like a traditional aircraft, like a traditional fixed-wing aircraft, except that it's going to have a number of electric propellers across it. And because of that, and because of concepts like blown lift, it can actually take off and land in very short distances, typically something the size of a soccer pitch. And as a result, again, you open up regions for travel without all of the associated infrastructure of a traditional airport. And then the last group I would mention are uncrewed cargo vehicles. And these are folks like Otis or Elroy or Pipistrel. And the idea here is, how do we move goods in the same way, electrical, vertical takeoff and landing, cruising someplace and then dropping them off, but either remotely piloting or using some level of autonomy on those vehicles that allows you to operate them at a lower price point and with a lower environmental footprint. And so my group is dedicated to these types of vehicles. We were created back in 2020, and we had two foundational principles. One is we want to support technologies that are going to allow people to go 100 miles in 45 minutes. And so that opens up geographies and ways to travel that don't exist today. The other is we wanted to support technologies that would allow same-day delivery of goods anywhere in the developed world. So think of an artist in rural Arizona finishing a piece of art, packaging it up, and that same day it would be available to a buyer in Midtown Manhattan or in Rio de Janeiro. So hopefully that provides a little bit of a context of the vehicles we operate on.
Yeah, that's a great summary of kind of the opportunity across this landscape and the technology that's driving it. What's the current state then of UAM in the larger aviation landscape today?
You know, these vehicles are operating today. One of the biggest misconceptions is that this is aspirational. Folks like eHang and Autoflight are flying passengers in China today. They're generating revenue, they're developing operations, they're figuring out their business model today. And then in other geographies like the UAE, folks like Joby and Archer have started initial developmental flights to figure out what those ideal routes are going to be in those areas. So I think the most important thing is that this isn't aspirational, this isn't a pipe dream. These vehicles are flying today, and as those certifications and rulemaking get finished, you're going to start to see more and more of them in different parts of the world. I think it's important to highlight is not only who the major players are, but the level of investment that they've made in this space. Because another misconception that you hear a lot is these are a lot of Silicon Valley startups who don't realize how much time and effort and money is going to be required to certify and operate one of these aircraft safely. Four of the biggest players in this market, Whisk is a division of Boeing, Citi is a division of Airbus, Eve is a division of Embraer, the third largest aircraft manufacturer in the world, and Pipistrel and eAviation are divisions of Textron, another massive aircraft manufacturing company. So these are serious, credible players who know what it's going to take to build and develop these aircraft. The other group I would mention that's maybe even more interesting is folks like Toyota via Joby, folks like Stellantis via Archer, folks like the Hyundai Motor Group via their division Supernal, and folks like Honda, who are investing massively in developing vehicles in this space. And I would suggest they're not doing that because they want to be the next Gulfstream. They're doing that because they fundamentally believe that these vehicles are going to change how people and goods move. And ultimately, it's going to change the demand for their ground transport solutions. And so they want to be an integral player of this ecosystem that is created by these vehicles. So that was long-winded, but that's the state of the union today.
What are some of the key technologies driving the development of UAM? And then how does the work Honeywell is doing come into play?
You know, we have an amazing portfolio within the Aerospace Technologies group, and we utilize all of it with these customers because they're starting from a clean sheet. And so I like to say we don't make the vehicle, but we make the eyes, the ears, the brains, the heart, the lungs, and the muscles. And if I can spend just a minute sort of thinking about each of those areas. You know, the eyes and the ears, we make sensors and navigation systems that allow these vehicles not only to know where they are in space, how they're oriented and where they are physically, but what's around them, right? What are the obstacles they're going to face and how are they going to operate around them? When we think about the brains, these are things like our flight control computers that take an input from the pilot and they turn that into actions that the vehicle is going to take. Things like our integrated cockpit, which gives the pilot situational awareness and key inputs. When we think about the lungs, we make cooling systems for these aircraft. Because these aircraft are primarily electric, they generate a ton of heat. And Honeywell makes these very small, very powerful cooling systems that not only keep those systems cool and the batteries cool, but keep the passengers inside those vehicles cool with a much smaller footprint. And then the beating heart of these vehicles, the propulsors that allow it to go, we make the electric motors that propel these vehicles. And last but not least, the muscles. So I talked about that input from the pilot that provides a signal to the brain, hey, you have to do something. We also make the electromechanical actuators that are the something, right, that turn the flap, that tilt the rotor, that allow the vehicle to turn and take action. So if that sounds like a compelling sort of tip-to-tail set of solutions for all the problems that these vehicles face, we have an unmatched portfolio in terms of what we do here.
So what are some of the other trends in the UAM space that are exciting to you?
There's a couple that I think are very inspiring. One is we think about dull, dirty, and dangerous missions that can be performed by these aircraft. And so think about rescues in very challenging regions where someone gets trapped or gets dehydrated and using these vehicles to rescue someone. Think about things like delivering medical supplies, critical medical supplies to hard-to-reach regions. Things folks like Zipline are doing in places like Rwanda today, where they deliver blood and medical supplies to hard-to-reach regions. Things like spraying crops, which is a notoriously dirty and dangerous job. There are a number of players today using these vehicles to do crop spraying in a much more efficient way, as well as protecting, the pilot from some of those impacts. And last but not least, firefighters using these vehicles not only to provide situational awareness of where the fire is spreading, but to also apply the fire retardant materials to places that are hard to reach. So that whole sort of what are the missions we can allow these vehicles to do that are today very dangerous for people, I think is very inspiring. The other one that I think a lot about is what are these hard to reach regions and how can it open up their economies and the economies of these underserved regions via these vehicles. I'm a big snowboarder. And my favorite mountain here in the state of Arizona is notoriously hard to reach. It's a 4.5-hour drive. They're difficult roads. If I could go to Sky Harbor Airport at 7:30 in the morning on a Saturday morning, strap my snowboard to one of these vehicles, and be at the lifts before 9 a.m. when they open, I would certainly pay uber black prices, to do that. But that's just one view. That's just the view of the traveler. At the other end of that, it would open up economies in little towns like Show Low and Pine Top near that ski mountain in ways we can't even imagine. The goods and services that they would provide because of how it would change how people travel would be transformational for them as well. And I also like to think about this a lot like the early days of high-speed internet, where we only understood the tip of the iceberg relative to the missions that are possible, right? We didn't know what we were going to do with high-speed internet until it was available to us. And so while these are the short list of missions that I can see today, there's a whole second and third order that's going to materialize later as we start to appreciate what these vehicles can do for us.
Wow. Thanks for giving us such a great kind of overview of the outcomes that we can look to expect from this new technology. And I agree with you. I mean, I can't wait to see what we learn as we're working through all of this and drive even more of these types of outcomes. We always like to close our episode with a really fun question. And, our podcast, of course, is focused on the future. But when you were growing up, what was it that you wanted to do in the future?
That's a great question. I always wanted to be a writer growing up, and hopefully before I die, I'll have that opportunity again, and perhaps even telling the story of this amazing pivotal moment that I'm getting to be a part of in aviation, and more importantly, telling the story of the amazing women and men at Honeywell Aerospace who helped make it a reality.
Well, I absolutely hope you get to do that. I think it will be an incredible story. Thank you so much for sharing all of this with us today.
You bet. Thanks for the opportunity.